All right, so chapter 9, we're going to take a look at three sections, 9.1, 9.2, and 9.4. 9.1 and 9.2 are related. 9.4 is kind of its own separate thing, but we'll look at that. It has to do with conic sections. All right, so first thing, I'm just going to show you kind of some different pictures of parametric graphs. Okay, so when you graph things parametrically, you can get really different kind of looking graphs that we haven't seen before. Okay, you get this kind of graph. That one kind of maybe looks like a butterfly or something like that. And then here, kind of almost like a sine wave, but it kind of loops back on itself and crosses itself. So all of these graphs fail a certain test that we use a lot. Yeah, these particular parametric equations fail the vertical line test. Not all parametric equations fail it, but these three do. When we graph things like this in y equals, okay, those have to be functions. Okay, but when we graph things parametrically, and today we'll see that we don't always get functions. Okay, so the first thing is kind of the idea of what a parametric graph, how you write one. Okay, well, the first thing is if you want to write a parametric graph, you can't do it with just one equation. You need two separate functions. Okay, and the reason that you need two functions, and I'll come right back to this, is because when you write something parametrically, it looks like this. You have one equation that describes the x coordinate, or the x values of the coordinate, and you have another equation that describes the y value of the coordinate. So that's a little different. And that's the big difference when you do things parametrically. Two equations. One describes the x, and then a separate one to describe the y values. We're not used to usually having that. So these two functions, f and g, those are one of them would be describing the x values, one of them would describe the y values. And the other thing is, it talks about this interval. Well, when you graph a parametric equation, you're only allowed to plug in certain values for t, okay, from a certain number to a certain number, in this case from 0 to 1. Well, we call that an interval. Those are the numbers, it's the interval of numbers you're allowed to plug in for t. It's kind of like the domain for t. Okay, that's what the interval is. All right, so the idea is if you take all the ordered pairs that you would get by plugging in the numbers on that interval into function f, and then taking all the numbers on that interval and plugging them into function g, putting those together as coordinates and graphing them would give you a parametric curve. Now, curve doesn't necessarily mean that the graph is curved. Curve is just the name they give to a parametric picture. Okay, those are all curves, parametric curves. And to sketch these, some of these could be pretty complicated. I think I looked up the butterfly one. It was just insanely complicated to type in. These other two, not as hard to type in, but even when you're familiar with parametric equations, if I said, what would be the equations to generate this? Well, it can be tough to figure that out. Versus if I said, how would you graph that on the calculator? It would just be an x squared equation. It would be a parabola. Okay, parametric ones, we're not used to thinking about them, so they're a little harder to figure out. Okay, so the two equations that we use, okay, I used function f to generate my x values, function g to generate the y values. Those are called parametric equations. And t, okay, this is what you're changing. Remember, you are restricted to what you can plug in for t, and they'll always tell you what you can plug in. What is that called again? The restriction on t? It's the interval. It could be 0 to 1, it could be negative pi to pi, it depends. But that variable that you're changing, the t, we usually don't call it a variable. We call it a parameter. But it's just like a variable. The parameter is the thing that can take on different values. Again, restricted by your interval. So now when you graph something parametrically on the calculator, there's an extra step. Actually, a couple extra steps. One, you can't just type in one equation. You have to type in an equation for x and a second equation for y. Okay, and I'll show you how that works. And then the second thing you have to do is you always have to type in your parameter. And there's a spot on the screen to do that. And I think based on what we've done, you'll figure out where to find it. All right, it's kind of another way to say what we're doing and just putting some terms together in a way that makes sense. If you have a picture or a curve defined by a pair of parametric equations, then we can say those equations give you a parametrization of the curve. So come right back. But what I just put a box around, those two equations give me a parametrization of some curve. I don't know what the curve looks like. I'd have to sketch it, and we'll do that in a little bit. As you just saw on the first page, curves can intersect themselves. They don't have to. Pretty much anything you already know how to sketch. In fact, I guarantee you, everything you know how to sketch. Parabolas, lines, sine functions, cosine functions, roots, exponentials, logarithms. Every function we've studied all year, you can do them parametrically. Actually, pretty straightforward, too. But now we can do even more than that. Okay, we can sketch all kinds of things that would be impossible to do as functions, because these are not functions. They fail the vertical line test. Right, so when you sketch something parametrically, there's a start point and there's an end point. On the graphs that I gave you at the beginning, it's kind of hard for me to tell where the start point and end point is. In fact, I think it might connect. That's how these all look to me. But you could have a graph that does something like that. Start point and end point. And somehow it goes from the start point to the end point. Could be linear. Could be a curve. Could be all kinds of things. But that's a clear example where you have a start and an end. Or it could be the other way around. That could be the end. That could be the start. Where the start and end points are, it's going to depend on what they give you. Okay, but I can't just look at that picture and say where it starts and ends. I have no idea. This is one, that's the other. Without more information, I can't tell you. So what controls where a parametric curve starts and stops is the interval. Okay, it's the domain of your parameter. That's the interval. To figure out where your start and end points are, there are 4 calculations you need to do. You need to calculate the starting x and starting y, the ending x and ending y. Those are the 4 values. Let me get rid of that. A controls where your start point is. If you plug A into the function that generates the x's, and then plug A into the other function that's generating the y's, that'll give you your start point. B, that's going to control the other endpoint. Okay? If you plug B into your formula that's generating the x's, and then into your formula that generates the y's, that'll give you your endpoint. Okay, so next what we're going to do is try to figure out where a graph would start and end, and then I'm going to take the graph that we do in the example, and we'll do it on the calculator, just to practice typing it in. So any question on the 4 calculations you need to do to get the starting x and y and the ending x and y. And you'll always be given the interval. Usually it's a closed interval, but it can be a half open, half closed interval. We are going to see something like that later on today. Okay, so here's our first parametric equation. It's kind of like a system. There's two of them. We have a formula for x and a formula for y. And they're telling us the domain for t. They're telling us the interval is 0 to 1. So you are only allowed to plug in numbers for t that are between 0 and 1. Okay, I want to find the endpoints of the curve. Okay, in the interval, what number is going to control where my parametric curve starts? 0. Okay, so if I plug 0 into some formula for x's, I'll figure that out in a second, and then I'm going to plug 0 into the formula that's giving me the y's. What value is going to control where the curve stops? 1. And I need to plug that in for t in the x formula. And I need to plug that in for t in the y formula. Okay, now we need to do those out. So let's start with plugging in 0 for t in the x formula and the y formula. Okay, if you plug 0 in for t in the x formula, what do you get? 1. Yep. And if you plug 0 in for t in the y formula, what do you get? 2. That's the start point of your curve. 1, 2. Now the end point. What if you plug 1 in for t in the x formula? Yep, -1. And what if you plug 1 in for t in the y formula? 1. All right, so basically what I know, let's go like this. Right now is I have a start point at 1, 2. I'm going to make that a little bigger. So 1, 2. And I have an end point at -1, 1. -1, 1. What I don't know is how it's going to connect to those points. Is it straight? Is it curved? Is it whatever? It is linear. Okay, this is going to be linear. But I want you to watch how it draws it. That's the start. That's the end. So when the calculator sketches it, it's going to draw it just like I did there. It's going to start in quadrant 1 and draw towards quadrant 2. Okay, and it's going to draw it quickly. So you got to kind of watch when I do it. All right, so let's see how we do this on the calculator. So the first thing we need to do is change the mode to parametric. So if you go to mode, and then the fifth option down, it says function, parametric, and polar. We're going to use all three of those. But for today, we're going to go back and forth between parametric and polar. Okay, so press parametric. And once I put it on parametric, I can quit. Now, when I press this button right below mode, what letter normally pops up? X. Well, now that I've switched it to parametric, it's going to give me a T. Okay, whenever you write parametric equations, that's just the letter they use. We normally use lowercase t. The calculator always uses capital. That's fine. Okay. And when you press y equals, now it's set up for parametric equations. Okay. To graph something parametrically, you have to type in an x and a y. If you leave one of them blank, it won't work. So under my first x equation, I'm going to type in 1 minus 2t. And under my y equation, 2 minus t. Now that's not the only thing we have to do to graph it. There's one other thing I have to set. And what's that? Yeah, I have to go to Window, and now there's a little bit more information there. You still have your x min max, your y min and max, but now you've got a t min and max. Well, that's the minimum value for the parameter. That's t min. That's t max. So it's 0 to 1. Okay. And I'm just going to hit graph. T-step is important, but just leave it, just leave it at that for now. Okay. And when I hit graph, watch the way that it draws it. It should go from quadrant 1 to 2 very quickly. People see it? If you zoom in a little, it'll slow it down a little because the calculator has to draw something bigger. Maybe it took a fraction of a second longer, but there's your graph. And I'm going to zoom in, and I'm going to save this picture. -4 to 4. Just put that right there. Okay, so there's our graph. It's basically a line segment. All right, so now t-step. I want to take a look at what that does. What was the starting value? What was t min? 0. And we're going up to, what was t max? 1. Did anybody have a guess what t-step does? Think about going from 0 to 1. How often it puts a dot. So in other words, to graph what it just did, it's going to start by plugging 0 in to the x and y equation. Right? The next value it's going to plug in, and I'm going to round it off, is 0.13. So it's going to skip everything up to 0.13, and it's going to plug 0.13 in for x and y. Then it's going to plug in 0.26, then 0.39, and let's keep going and see what happens. What would be the next value? Point what? Yep, so we got 52, and then 65, 0.78, 0.91, and what would be the next one after that? Well, going by our step, which is 0.13. No, it won't do any more, because what would the next one be? 1.04. But it's not going to get to that one because it can't go above 1. So what's going to happen is by putting in a step of 0.13, you're actually not drawing a little bit of the graph. Okay? What could you change your step to so that it's an increment that would land you exactly at 1? Yeah, if you did 0.1, now it's going to graph 0, 0.1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1. So now you'll actually get a graph that probably not something I can really show you clearly, but let me put these next to each other and see if we can see just a little bit of a difference. If I trace, well, actually it's not to scale because I didn't draw them the same exact. Actually, those are almost the same size. If I put them exactly the same size, or pretty close, and then trace this part as accurately as I can, and move that segment over here, can you see how that segment is a lot shorter? I mean, relatively, versus here, it's almost exactly the right length. So you're getting a little bit more of the drawing that you should have gotten that you didn't get because of your t-step. Okay, so your t-step is like it's like the resolution. It's how often do you want the calculator to plot a point to get the picture for you. So what if I did a t-step of 0.6? What values would the calculator graph to generate the picture? It would graph when t is, what would it start at? 0. And then 0.6. Would it do 1.2? No, because it's beyond. So really, it's only going to graph from the 0.0 and 0.6. You're going to lose a lot of the graph now. Okay, we've lost even more. So in general, try to pick a t-step that divides into your t-max. Okay? For a line, it's not, you can see it's important, but for other shapes, it's even more important. What kind of shapes do you think the t-step influences even more? Circles, anything that's curved. Because if you wanted to graph a circle, and let's say you picked, a finite number of points. Parametric equations always connect one point to the next using a line segment, always. So if that's all you did was 5 points, that's what your circle would look like. If you want a higher level of detail, you're going to have to put in more points, and then the calculator will connect each point to the next using a line segment, but overall, it'll start to look more curved. Okay, so that's what t-step does. The other thing you want to be careful is you don't make it too small. What's going to happen if I go by hundredths? And I want to go from 0 to 1 by hundredths. How many points is it going to have to graph? Yeah, like 100 or maybe 101. I always get confused with that. But yeah, it's going to have to graph a lot of points, which is going to do what when I hit the graph button? What does that mean? It's going to take a longer time. Much slower than before. And eventually, the screen can only show you so much detail. So is it worth graphing 100 points to get that line segment? I don't think you need that much detail in this picture. Okay? And it would be even worse if you put in 0.001. Then it would graph 1,000 something points to get that line segment. Okay? With anything that we're going to do, you don't need that much detail. Okay? But that's what t-step does. So kind of a different idea, something we're not used to with functions. Any questions on how to find the start point and end point of a curve? Okay. So the next thing we're going to look at is how can we take a set of equations, just like we had in example 1, and convert this to something that we're used to. I want to get rid of the parameter. I want to eliminate the parameter. So in other words, I want to eliminate the letter t. So by eliminating it, we're going to turn this into a function. What two letters do we use when we have functions? We use what? Well, for names of functions, but I'm thinking like for variables, like if you're going to write the equation of a line, like in Algebra 1. What two letters are in the formula for the equation of a line? X and Y. So my goal here when I'm done is to have a formula that's Y equals, and then an X on the other side. No T. Okay. Any thoughts on how I could do that here? How I could generate an equation using these two that just has X's and Y's in it? Yeah, solve for t in which equation? If you solve for t in the y and then fill it in here, you're going to end up with x equals. Yeah, let's solve for t in the x equation. So we get x minus 1 equals negative 2t. And then what would I do to get t by itself? So I could put x minus 1 divided by negative 2 equals t. Or if I wanted to separate this out into two terms, what's negative 1 divided by negative 2? Yeah, 0.5 or 1/2. And what's x divided by negative 2? Negative x over 2 or minus 1/2 x. Okay, so I just separated it out and did the division. Okay, so that's t. Now fill that in right there. And you'll have a formula. So we get y equals 2. Be careful, why do I have to put parentheses around the t? I have to distribute that negative. That's why I kind of wanted to get rid of the negative with the 2, so I didn't have as many negatives to deal with. So I have 1/2 minus, bless you, 1/2 minus 1/2 x. Okay, what's 2 minus 1/2? 3/2 or 1.5, same thing. 1.5. So that's 2 minus 1/2. And now I did this part. I still need to do this. What's minus 1/2 x? Plus 1/2 x. Okay. So there is your equation that we just did parametrically as a function. Okay. So now I'm actually going to take this and put it right here. And now I'm going to go back to function notation and I'm going to type that in, 1/2 x plus 1.5, and I'm going to see what it looks like. Any thoughts on how it's going to look different or the same, or any thoughts what's going to happen when I type that in? It's not going to stop. That's a problem. Okay, I've got the same window, so the scale is going to be the same. But the problem here is I'm getting more of the picture than I want. Okay? So what do I have to restrict in this picture? I have to restrict the x's. Okay? I have to restrict the domain. And the way I have to restrict the domain is look at the start and end x values. What was my starting x value parametrically? The starting x value. So starting x value was 1. Okay, so I'm going to put that condition in, that I have to be at most 1. And where do I end? I end at -1. My x's have to be between -1 and 1 in order to get the same picture. So the way you type it in is just like this. So x is greater than or equal to -1. Another parenthesis, x, second math, is less than or equal to 1. Now it's not going to be perfect, but this is as good as you can get. So the calculator wants to draw something everywhere. So it's going to draw along the x-axis when it doesn't know what else to do, but you can ignore that part. Okay. Just focus on the picture. Which I'll bring up in a second. There we go. And on the left, you're looking at it as a function. On the right, you're looking at it parametrically. But they're the same graph. Okay? So any questions on how we eliminated the parameter there? Okay, so it's important that the original curve, okay, the one that you had parametrically, was just a small segment. So you have to write the restriction that goes with that function, which would be this. Was it -1 to 1? Is that what we typed in? That is your restriction. how would you type in what I have in red and black here? You have to type it in just like that. You have to put the conditions in parentheses. And you can't do a conjunction the way I typed it here. I think you have to do each one separate. I've tried putting the x in the middle and it doesn't work. Yep, and the original function as well. So if you want to type in a condition, that's how you have to do it. We did that with piecewise functions. I think I was back in chapter 1 or 2. Great, any questions on that? So it's not always possible to do what we just did, okay, to eliminate the parameter. Because sometimes you could have an equation like this. If I said x equals 3 to the t minus t, you can't get t by itself there. If I got rid of the exponent on 3, then you could easily do it. If I got rid of the t on the end, then you could just take a root of both sides. But the problem here is if you've got it as an exponent and a term, it's impossible to use algebra to isolate t. So if I give you a problem to eliminate the parameter, it will always be doable. Okay, but if you just make one up randomly, it might not. Okay, this is one that's doable. Okay, so it says eliminate the parameter. So to eliminate the parameter, which equation do we work with first? X or y? X. And what do we do with the x equation? Get t by itself. Okay, so what does t equal in the x equation? Yep, x plus 1. And now, what do I do with that x plus 1? For t. Right there. So we get y equals x plus 1 squared. You could FOIL it out to x squared plus 2x plus 1, but I actually think it's easier to just leave it factored like that. Okay, so have I done it? Have I eliminated the parameter? And is that all I need to write?
No.
No. I have eliminated the parameter, but I haven't written down my restriction. There's got to be some restriction on the domain here. Is the restriction going to have the equal to's, or is it just going to be like a less than? It's going to have the equal to's, because the original interval had brackets. Now I just need to figure out the restriction. What number here is going to control where the x's, well actually, tell me what number is going to control where the x's start. What number?
0.
0.
Double 1.
Yeah, so that's the number that controls where it's going to start, and then you fill it in to find out where they start. So 0 minus 1 is negative 1. I'm just going to write that off to the side because I don't know if that's going to be smaller or bigger than what I'm about to do next. What number is going to control where the x's stop? 3. And where do the x's actually stop? 2. So now I know my x's are between negative 1 and 2. So this is a parabola only graphed between negative 1 and 2. And it's a parabola shifted. How? How is the parabola shifted here? Yep, Tanya? It's a horizontal shift. Which way? To the left. Yeah, it's to the left and it's 1 unit to the left. Okay, so any questions on eliminating the parameter or finding the domain there? Okay, so as I said earlier, it's not always possible to eliminate the parameter. Okay, and I showed you an equation that you can't do that with. But you can always do the reverse. You can always take something that doesn't have a parameter and put one in. And kind of the cheap way to do that, really, really easy way, is just to say, all right, I'm going to change all my x's to t's, and then rewrite the original problem with t's instead of x's. Okay, that's kind of the easy way to change something to parametric equation. Literally just change your x to t, Say you're going to write t in for all the x's, and then replace x with t in the y equation. And that makes it parametric. Okay, so if I did that on this problem, what would I let x equal? Yeah.
Would you let it equal t?
Yeah, just let x equal t. And then what would my y equation become? Yeah.
3t cubed plus 7t. No, b.
Yep.
Plus 7t cubed minus 8t squared plus 2.
Yeah, that's it. You've just turned that into a parametric equation. It's such a simple parametric equation that why would you even bother? Why not just leave it as a function if you're just going to do that? But you could. Okay, so let's take something like, let's call that 3a. Let's try a different one. Does everybody have the original? Let's do y equals just a simpler one. 2t actually, let's do it like this. Y equals 2x squared. There's a function, and I want to convert that to parametric. I want to do it two ways. How would I do it the way we just did it? Yep, Tiny?
X equals t,
Yep.
and then bar b 2t squared.
Yeah. There's one way to type that in parametrically. Now, I'm going to start you off with a different one for x. Just a little different. What would y be if I made x t plus 1? Yes. And the reason would be because let's take this and convert it back. Let's eliminate the parameter and see if we get that back. Well, the first thing you do is take your x equation, solve it for t. And what's t? X minus 1. And now if you take x minus 1 and fill it in right here, what's x minus 1 plus 1? And you get x, 2x squared. It goes right back to what you started with. So here is a different way to eliminate the parameter. And they're both correct. In order to get the exact same picture, what would be different, though, between this one, the one on the left, and the one on the right? What would you have to change a little bit?
Your viewing window,
What about the viewing window?
because that one's going to be shaded.
Well, these should be the exact same picture if you do it correctly. But what would you have to adjust to make sure you get the right start and end points? The interval. This graph would have a different interval than that graph. You could keep the min and max for the x and the y the same because they should be the exact same picture. But you would have to set the right interval. Like let's say this one had an interval 0 to 2. What would this have to have an interval to be comparable to the picture on the left? Yeah. If you set that picture with an interval of 1 to 3, is that going to be... Yeah, I think... no, not quite. -1 to 1. Because now think about your x start. It starts at 0. It ends at 2. Plug in -1. -1 plus 1 starts at 0. Plug in 1. 1 plus 1 is 2. So now if you graph what's on the left and what's on the right, those two pictures would look exactly the same. But you have to adjust the intervals. Okay, any question on that? So I might have you convert something to parametric, but I might ask you to do it two different ways. Okay, there's always the easy way, and then this way sometimes you have to think about a little bit, and then you have to think about your interval to make them match. All right, so the next thing I want to look at is a circle. Okay, so circle, now we're looking at a curve. So that means you got to have enough detail to show the curve correctly on the screen. So we have to think about how we would describe an xy point on a circle. What's different when you think about an xy coordinate parametrically versus thinking about it as a function? What's the difference when you write things parametrically? They're separate. You want to think of the x coordinate totally separate from the y coordinate. Okay? They have nothing to do with each other. Totally separate. So, if we had a coordinate or a point, okay, just on that circle, what would I have to draw on that diagram so that I could start to think about the x and the y as totally separate things? Pretend like that's a position vector from the origin drawn towards that blue line. Now, right now you've got a segment here that's a combination of x and y. I want to separate it into its components, horizontal and vertical, just like we did with force and velocity. So what shape are we going to make out of that? We're going to make a right triangle. So I'm going to draw a line segment from the point perpendicular to the x-axis. Here's my x component. Here's my y component. All I need to do is come up with two separate formulas, one for the x and then one for the y. But what else would you have to know here? I mean, that's going to be your radius of the circle. But you'd have to know something else to figure out the formula for x and y.
Is it a unit circle?
It's going to be a circle of radius r. We don't know. It could be a circle with a radius of 2, 3. It doesn't really matter once we get the formula. But there's something else in that triangle you need to know. You need to know which angle. Yeah, the one by the origin. You need that angle. Right there. And what do we normally call that angle? Theta. What do you think I'm going to call, what letter do you think I'm going to use to represent it now? T. The angle is the thing that is changing. Okay, the parameter, when you write something parametrically, is the thing that is changing. If you change that angle, you change the x and the y automatically. Okay, so now let's come up with two separate formulas. What trig function would I use that would involve x and the radius? Cosine? So it would be cosine of, yeah. And that would mean x equals what? There's one of your parametric equations. X is r cosine t. And what about y? R sine t. So if you want to graph a circle with a radius of r, those are the two equations you type in. Because sine and cosine break apart the coordinate into its x and y values as two separate formulas. Now, since we're using sines and cosines, what do we have to be careful about now that I didn't really have to be careful about in this problem, or this problem, or the first problem? Yeah? So we still have to think about the domain in the last ones, right? We had these domains or these intervals that we had to write. But there's something else we got to be careful about. How did we describe the equation of the circle? What did we use?
X and Y.
How did you define x and y, though? What did we use to define the x? And then what did we use to define the y?
R.
Okay, so what do they both have an r in them, but I'm focusing on the other part there.
Sine, cosine, P.
And what are sine and cosine?
Trig function.
Trig functions. So anytime you use a trig function, what do you have to be careful about? Well, what is t? Focus on t. What is that? It's a what? T is an angle, yes. One more step. So what do we have to be careful about when we're working with angles?
That there's two answers.
No, there'll only be one answer. Only get one answer. But what do we know about angles?
The degrees.
Could be in degrees or radians. So whether or not you're in degrees and radians is going to affect your T min and T max. How are you going to get a complete circle? You have to think about what to set T min and T max to. If you don't set it big enough, you might only get a half circle or a three-quarter circle. So what would be the equations for a circle centered at the origin with a radius of 2? Let's start with the x equation. Anyone think they know what the x equation would be for a circle with radius 2? Yeah, Matt?
Wouldn't it be 2 cosine T?
Yep, 2 cosine t. And how about the y? 2 sine t. Now, do we want to do degrees or radians? Degrees, okay. So if we type that in degrees, let's switch the mode to degrees. I'm still in no, I'm not in parametric. So we'll switch back to parametric. Type in the two equations you just gave me. 2 cosine t and 2 sine t. Okay. And am I ready to graph? What do I need to do? Do what? Okay, we need to adjust some stuff. Let's look at the mins and maxes for the x's first. I've got a circle with radius 2 centered at the origin. So what's the highest and the lowest that this circle is going to go? And left and right? Yeah, so I could do -3 to 3 and -3 to 3. That's fine. What else do I need to set? Okay, yeah, I think the t-step is too small. I think 0.1 will be sufficient. What else? The t-max. If I hit graph right now, I'm not going to get a circle. I'm going to get that. Let me see if I adjusted everything right. -3 and 3. Where is my...
You did it wrong. You put it in like X.
Thank you. Like, where is my x-axis? Okay. Did I do it again?
Yeah, you changed it. You wrote the scale.
I think that it's just set the same as the other scale. Is there a y scale? Yeah, 1. All right, so when I graph it, that's all I get. I don't really get much here. What's wrong? What do I need to... well, we already said what's wrong. The T-max. What does T-max have to be? 2? Let's try 2. No. We want to graph a full circle.
360.
The parameter has to go through every value before it repeats, which is all the way to 360. So when you graph 1, you're not getting very much of the circle. You're getting 1/360th of the circle. Now, it's going to look, see, that's what happens when your t-step is too fine. So what's happening? It's graphing by 0.1s from 0 to 360. How many points is that? How many? Going by tenths from 0 to 360. It's like 3,600 points. So,
All mine's faster.
so I think I can,
Just turn your calculator off.
yeah, I can just stop it. I'm going to adjust the window. 0.1 would have been fine if we did it in radians. I would say 1, or even 2, even probably 5. It's probably fine to do it in degrees.
What if you did 360?
You wouldn't get anything. Nothing would show up. Now, how come it doesn't look like a circle? I mean, it is, because it's crossing each tick mark at 2.
Stop it.
If the points weren't close enough, the edges would start to look less round. So the points are okay. But why doesn't it look circular? Well, look at the screen. What's the shape of the screen on the calculator? The screen is rectangular, but you've set -3 to 3 on the x and the same distance on the y. So you're putting the same amount of distance on each axis. The scale factor here is about 1.6. That's the ratio of the width divided by the height. So if you divide, or if you multiply your numbers here by 1.6, that'll make things look proportional. So now it should look more circular. That's the scale factor. So if you set your y's and then put in your x times 1.6 of that, it'll look the way it should. We're pretty close. Now, what would happen if I did t-step of 90? What values would it graph? 0? 90? 180? 270? And then it's going to go back to 360. So what you're going to do is you're just going to get a diamond. Because it's only graphing 4 points. What if I wanted to graph 6 points? What would I type in for my t-step? 45? Not quite. That gave me 8 points. 60. If you type that in, it's going to look like a hexagon, right? You get 6 sides. So the higher you set or the lower you set your t-step, the more points you start to get, and you can see it's starting to approach more of a circle. I think somewhere around 10, because that would give you about 36 points. That's starting to look pretty good. What's going to happen if I did something like that? Yeah, it's not going to give me a full circle. Where would it end? It would be the last t value. 350. It would get to 350. The next one would be 375. It can't do it, so you're going to see a little gap. So try to make sure that your t-step divides into your t-max. Otherwise, you're going to get a gap at the end. Okay. So what was the domain that we used for the parameter to get a full circle? And how would you write it? How would we write the domain for that, what we use for that circle?
0, 25.
If we did radians, but we didn't.
0, 360 degrees.
What else? I need more.
then a parenthesis.
Parenthesis. No, we didn't use another interval, just a
Alright.
single interval.
I don't know, it's a guess.
But you need a parenthesis.
Oh, that was a good.
Why not a bracket? Right. Just to kind of exaggerate it, if you started at 0 and then went to 360, you would be tracing that point twice. Okay? If you did 720, you would trace the entire circle 2 times. But you wouldn't notice a difference the second time because it would trace right where it did the first time. Or it might make it look a little bolder because sometimes it's just a little off. All right, so the last thing we're going to do is just look at some different graphs and see if we can figure out the windows. Okay, some complete graphs. Okay, so we're finding complete graphs of these equations. All right, let's start with this. If you take the cosine of anything between 0 and 4 pi, or even if you just take the cosine of anything, what is your answer always between? -1 and 1. So the cosine of anything is always between -1 and 1. And now, what are you multiplying the thing that I just circled by? T, which is between what? 0 and 4 pi. So, what would be the biggest value that you could ever get for x? 4 pi. What would be the smallest value?
0.
-4 pi, because that could be -1 times 4 pi. Now, I'm not saying it's necessarily going to hit those values, but I guarantee it won't ever be beyond them. Okay? It probably won't even get right to those edges. So I'm going to set my x min and max, at least as a starting point, to what we just said. Let's look at this. What is sine always between? Nope, not 0 and 1. -1 and 1. Sine is always -1 to 1. And you're multiplying it by a number that's between 0 and 4 pi. So what's the biggest your y value could ever be? If everything lined up just right, it would be 4 pi. And the lowest? -4 pi, right? Because sine can be -1. And if t was 4 pi, okay. So I'm going to set my y min and max the same. And what about my t min and max? What am I setting for that? 0 to 4 pi. Anything else I need to adjust?
Your t-step, maybe?
Yeah, t-step I would go by 0.1. That's probably pretty good. Yep, I need to put it back to radians. Okay.
The same, it's -4.
Yeah, the x's and y's are the same, so I got everything set on my window, but I haven't typed the formulas in yet. What do these formulas look similar to? Anything?
What we did before, but it's pretty much the same thing before, but we don't know what the radius is. Well,
What is the radius?
is the same as the degree.
Yeah, so what does that mean about the radius? Compared to what we did in the previous example.
The radius is changing, so would it be like an ellipse?
Well, the radius is constantly changing. Anybody know what shape that would be? If you tried to draw a circle, but the radius was just getting bigger and bigger, it would be a spiral. So, if we draw that, we're going to get a spiral. And because we went 0 to 4 pi, that's 2 revolutions. So you get 2 revolutions in the spiral.
Mine doesn't look like yours at all.
You got to set
True.
these equations, set everything the way I did in the window,
Worse.
set the mode back to radians.
Yeah, what you do. Yeah, I got it. Oh, what the heck? How'd you get that? You just thought.
Your t-step might be wrong. So those are all the values you should type in. If your t-step is like, let's say 2, you're going to get a spiral, but it's going to be like line segments. It's going to look kind of jagged. I'd say 0.1 looks pretty smooth. It's not perfect. I can kind of see it a little bit, but good enough. Okay, so there's that one. Let's look at this one. Okay, so these are not periodic functions. Okay? Periodic functions have to go back to where they started eventually. These don't. They keep growing forever. The spiral would just keep growing. It would never come back and repeat on itself. How about this function? 5 sine t. Those are my x values. Is it going to grow forever? No. What's the maximum that thing I just circled could ever be? 5. And the minimum? -5. So this is a periodic function, which means your x's are going to keep repeating. How about the y values? Are those going to be repeating?
Why is that one 5t cosine t and the other one is just 5 sine t?
Just the formulas. Yeah. What? So is this going to repeat back on itself? Well, think about what's t? Yeah.
So like when we wrote out like how to change them, I thought like the x had the cosine of the equation. Is it not always like that?
That was for a circle. These are different shapes. Yeah, so these aren't necessarily circles anymore.
So that always x is always the cosine for circle.
For a circle, yes. X we always do as the cosine and y is the sine. So let's start with cosine. What's cosine always between? -1 and 1. And now let's pretend the highest we went for t was, just to make it a little simpler, let's just go to 20. What's this product in the front going to come out to at its largest? 100. If t got bigger, would it eventually loop back on itself, or does it just keep getting bigger? Like if t was 50, would it repeat a y value we had earlier? No. This just keeps growing. If t was 50, it would be 250. If t was 1,000, it would be 5,000. The y values are not periodic. They just keep growing forever. So we're going to get a function that is periodic on the x. You're going to get repeating x values, but y values that just get bigger and bigger. So let's see what that looks like. So we've got 5 sine t. And we've got 5t cosine t. Okay, and we already said x values are going to be -5 to 5. So let's do -5 to 5. And what was the biggest that the y value could be? 100? If t was 20, just to make the math a little easier. Or we could also have -100. Let's graph it.
You put the negative.
Did I do it on the scale again?
You did the min 100 and the max.
Yeah, that will not work. So what's happening is you're getting x values that are repeating. They're just going -5 to 5. -5 to 5. And if you set your parameter, I think, did we say 20? Something like that? So watch the x value. 5, -5. 5, -5. It just keeps repeating. But the y's just keep growing. So you get kind of like this watermelon or beach ball that's kind of distorted a little bit.
Why did it stop again?
It stopped because I stopped at 20. If I went to like 22, it might go a little further. And if you just let t get bigger and bigger, you're just going to keep repeating.
So what was the x min and x max?
So for your window here, I would use those. T-min, my cursor kind of blocks it, but you just get that from the 0. Okay, and the last one we'll look at is this one. One thing I want you to notice is that there's a 5 in both spots there and both spots there. Okay, let's look at, are there any terms in either x or y that would just continue to grow if t got bigger and bigger? Five t, that's unbounded. If t gets bigger and bigger and bigger, let's say t is 1,000, you're going to have 5,000 minus something. This is fixed. 5 sine t can only alternate between -5 and 5. This is also fixed. Okay. What's the smallest cosine could be? Negative, and what's -1 times -5? 5. So my y values could hit 10. And then what's the biggest cosine could be? What's 1 times -5? So my y values are going to repeat. They're only going to go from 0 to 10, 0 to 10. They're going to keep going 0 to 10. But the x values are going to grow forever. So let's see what that looks like. So I'm going to type in, I'm going to do -15 to 15. They didn't tell me a parameter, so I'm just going to try that, see how it looks. X min. Again, I really don't know how big it's going to get. I'll try -75 to 75. I'm just guessing. If I need it bigger, I'll set it bigger. But my y values, I know, are only going to go from 0 to 10. Okay, I'm going to type in 5t minus 5 sine t. And 5 minus 5 cosine t. Okay, let's hit graph and see what we got. So we're getting these y values that just go 0 to 10, 0 to 10. And depending on how high I set my parameter, it's just going to keep doing that pattern. That's it. So we just get this kind of, these arches. Okay, and there's a special name for those arches. It's called a cycloid. You need to copy those and make them a little bigger. But in the formulas I have on the right, a is 5, and then it turns into the one on the left. All they did was factor out the number that was in common. But if you multiply it out, you have 5t minus 5 sine t, if you let a equal 5. And then you'd have 5 minus 5 cosine t. Now, if you take one of those, if you take one of those cycloids, just make a copy. Take one of them, which I'm not tracing perfect. Get the idea. Can I? Oh, perfect. Take that and flip it like that. You basically get what I just drew in black. That one's shaped a little different, but it's an upside down cycloid. Okay. Basically, the short version here is if you put a ball right at the origin and let it roll down to point P, and your curve was in the shape of a cycloid, it would get there the fastest. Like if you took a board and put it straight and you rolled the ball down it, it would take longer. If you had any other shape connecting here to there, that line in blue, it would take longer for the ball to roll down than the one in black. Okay, so a cycloid gives you what's called the curve of quickest descent. So if you were making like a roller coaster, and you had somebody at a high point, and you wanted to get them to a low point and get there as fast as possible, you should shape the track in the shape of a cycloid. Okay, so the homework, it's on 481. Okay, that's due a week from today on the 10th. And our test is on the Thursday, because that's the 13th. Okay, so on page 481, 1 to 5. Actually, I guess you could just say 1 through 17 odd. That might be a little easier way. And I'll put that on there.